Hi and welcome to video 1 on index laws, where we're going to review the basic index laws and stuff that you should have done in the past, of course assuming you're studying the 10 Math B course, and otherwise this may be new to you. So just going through quickly what we will cover. We will look at reviewing the power of 0 and the power of 1 law. We'll look at multiplication division laws, and we'll look at the power of a power law, as well as just some examples and some expansions. So let's get into it. First of all, I'm going to go through some of our basic laws and just write them down. And then in some cases, I'll give you reasons why. I'm going to try and build up that reason why. Obviously, in the first instance, you just need to know the law and how to use it. But if you understand why, that's going to really help you. So let's start with index law, which I'm going to arbitrarily call index law number 1. And so index law number 1 is that a to the power of 0 is equal to 1. In fact, this is just saying anything to the power of 0 is equal to 1. And that's true for any number. The second index law is a to the power of 1 is equal to a. So anything to the power of 1 is equal to itself. And again, this is true for any number. The third index law is a to the power of m times a to the power of n is equal to a to the power of m plus n. Now, this is the first time I'm going to go into a little bit of a why statement. Why is this true? So why is it that when we multiply two indices, we can add the powers? Let's imagine a really simple statement. 4 to the power of 3 times 4 squared. Now, if I write this out using our index notation, and so this is a good reminder of what an index actually is, we have 4 times 4 times 4, close brackets, and I multiply this again by 4 times 4, and I get 4 cubed is here because there's 3 of them, and 4 squared is here because there's 2 of them, but when I expand the brackets and put it all together, I end up with 4 times 4 times 4 times 4 times 4, and that of course gives me 4 to the power of 5. So you can see here that adding the 3 and the 2 is a shorter way of recognising this expansion of 4 to the power of 3 times 4 to the power of 2, which is not so bad. But if you get a question like 4 to the power of 15 times 4 to the power of 162, we don't want to have to write down all those 4s. So there we have it. A to the power of m times a to the power of n equals a to the power of m plus n. It's probably important here that I just make a quick note. This a is called the base. Over here I had a base 4. This rule only works if the bases are the same. So in red I'll just show you a not example of the rule. We cannot say that 2 to the power of 6 times 3 to the power of 2 equals anything to the power of 8. Because we can't just add the powers when the bases are the same. And often I see people grapple with this and decide to make it a 6 here. 2 times 3 equals 6. But when we're doing index laws, we don't multiply the bases. The base stays the same. As you can see, the 4 here has stayed as a 4 here. So that stays the same, and we can only use this law if the bases are the same. Now you'll see I've ruined my list here and I've now got a gap. So I'm going to put down index law number 4. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. So it works in the opposite way. And again, I'll show you a really quick example without the fluff. But let's imagine this time 4 cubed divided by 4 squared, which can be written as 4 times 4 times 4 divided by 4 times 4. And I'll put that in brackets to make sure we do the operations correctly. And so we can write this down now as a fraction, or another word for a fraction is a quotient, which will start becoming important for you as well. So writing it down here with a denominator means that we're using a quotient. And if I write it down with a denominator, as a fraction, the top divided by the bottom, you can see here that the 4 here will cancel that 4, this 4 will cancel that 4, leaving us 4, which according to rule number 2 is 4 to the power of 1. And of course 1 is 3 minus 2. So you can see how that law works. So let's have a look at a couple of examples very quickly of this law in operation. Example number 1. 2 to the power of 4 times 2 cubed. In this case, I'll write down 2 to the power of 4 plus 3 and that's equal to 2 to the power of 7. It's really important to show some level of working between, particularly if you're in an assessment situation. We want to see that you know how to do this law, not that you know how to put these numbers into your calculator. Second example, x squared times x to the power of 5 divided by x cubed. In this example, I'm going to start just by working in order, so I'm going to write down x2 plus 5 divided by x cubed, and that becomes x to the power of 7 divided by x cubed, and this of course is x to the power of 7 minus 3, which is equal to x to the power of 4. Technically you could do this in one line, 2 plus 5 minus 3, and that would be fine. I just want to build out the example for you. 4 plus 3xy to the power of 0. And in doing this example, you'll notice that it doesn't look quite the same as the last examples. There's no multiplication sign, so they're not asking us to use index law number 3 or 4. This is just an example where we need to recognize that it is 4 plus something to the power of 0, which is equal to 1. Anything to the power of 0 equals 1, even 3xy. And that, of course, is equal to 5. So there's our answer there. And lastly, example number 4, x times x to the power of 4. Now, I've chosen this example very specifically just to point out one fact. It's quite a simple example, but the fact that I want to point out is that if you have an x, that means x to the power of 1. And so if you're looking at this going, well, I need to add the powers, but I'm not sure what the powers are, well, it's x times x to the power of 4 is x to the power of 1 times x to the power of 4, which is x to the power of 1 plus 4. And that, of course, is x to the power of 5. So there's my examples of the first 4 index laws. So moving forward now, I just want to show you another couple, and then we'll probably leave it there. So here are my last couple of index laws. Index law number 5. And index law number 5 is an expansion law. X to the power of n to the power of m is equal to x to the power of nm. So if you have a power of a power, then you just multiply those two powers together. And again, let me show you why. If I do something like 4 cubed squared, well, this is equal to 4 times 4 times 4. Squared means we multiply it by itself. 4 times 4 times 4. And of course, this is equal to 4 to the power of 6. There's 6 4s there. 3 plus 3, or 3 times 2. So you can see that this law works. Index law number 6 comes in 2 parts, and it's the last one I'll talk about today. Another expansion law that is probably fairly trivial, but if you are expanding x over y to the power of n, or x times y to the power of n, then the power is applied to everything inside the brackets. So we end up with x to the power of n over y to the power of n, and here we end up with x to the power of n, y to the power of n. And we make sure that that law holds for every value within the brackets. Now, I'm not going to do any examples on these index laws because in the next video I'm going to talk about negative indices, and in that video I will be doing a couple of examples that involve these laws specifically. So if you follow the next video, then you'll be able to use those examples. Thank you very much.